Look up. Out there, in the silent, velvet darkness, our world hangs like a single, breathing jewel. A blue and white marble, swirling with life, unique in its fierce and fragile beauty. For all of our searching, for all the long nights we have spent aiming our telescopes at the void, we have found nothing else quite like it. This planet is a sanctuary, a ship sailing through an endless, empty ocean. We are its crew, the inheritors of a 4-billion-year-old miracle. From this vantage point, high above the continents and the clouds, our history seems impossibly grand, our dominance over this world absolute. But this perspective, the one of a species that has learned to look down upon its own cradle, is new. And it may be dangerously naive. Let's turn our gaze back down, past the shimmering atmosphere, and land on the parts of our world that feel the most alien. Come with me to the Atacama Desert in Chile, a place so dry, so utterly barren, that scientists use it to simulate the surface of Mars. Stand in the Danakil Depression in Ethiopia, a volcanic nightmare of bubbling acid pools and toxic yellow sulfur fields, a landscape that whispers of a planet's hellish birth. These are not just remote locations, they are wounds in time. They are places that show us how easily the vibrant, green veneer of our world can be stripped away, revealing something ancient, hostile, and indifferent beneath. They remind us that the Earth we know is just one chapter in a very, very long book. And we have only read the last page. What if we are not the first? It is the most profound question we can ask. Not the first intelligent life in the vast, star-dusted arena of the cosmos, but the first, right here. What if, deep in the geological scars of our own world, or in the acid clouds of Venus, or beneath the red dust of Mars, lies a warning? What if another intelligence rose on this very planet, in a time so remote our minds can barely grasp it? A civilization that built, and dreamed, and looked up at the very same moon, only to vanish so completely that not a single trace of their story remains. A ghost civilization, whose entire existence has been ground to dust by the relentless machinery of deep time. The immediate objection, of course, is the evidence. Where are the cities? The monuments? The bones? If an industrial society, a people who built with steel and concrete, had existed just a few million years ago, surely we would find something. But this is where our human-centric timescale fails us. A few million years is not a long time for a story, but it is an eternity for a stone. Over such a span, the Earth erases everything. The slow, unstoppable power of plate tectonics would have carried entire continents to fiery graves in the planet's mantle. Mountain ranges that saw their rise would have been weathered down to sand. Glaciers would have scraped landscapes clean, and rising seas would have buried their coastlines under kilometers of sediment. A city of glass and steel would last no longer than a footprint on a beach. In 10 million years, the Earth would not just bury a civilization, it would digest it, leaving not a fossil, not a ruin, not even a ghost. This is not just idle speculation. This is a serious thought experiment, a question posed by some of our most brilliant minds. It's called the Silurian hypothesis, named by astrophysicist Adam Frank and NASA climatologist Gavin Schmidt, after a race of ancient reptilian humanoids from the television show Doctor Who. But its whimsical name belies a chillingly rational core. The hypothesis doesn't claim that a lost civilization existed. It asks a more fundamental question: if one did, how could we possibly know? How would you search for a needle, not in a haystack, but in a haystack that has been burned, buried, crushed into rock, and then scattered across an entire planet for 100 million years? You would have to change what you were looking for. You would abandon the search for tangible things, for pyramids and tools, and instead, you would search for shadows. You would look for the lingering fingerprints of a global industrial footprint. You would skin ancient layers of sediment not for fossils, but for unnatural spikes in carbon from the sudden, voracious burning of fossil fuels. You would hunt for the chemical ghosts of their technology, the faint, persistent traces of synthetic molecules that nature could never create on its own, like plastics, steroids, or industrial pollutants. You would look for scars in the geological record itself, evidence of a planet pushed to the brink by its inhabitants. And what if the trail isn't here? What if the crime scene is next door? Our solar system is littered with ghosts. Venus, our sister planet, may have once been a temperate, water world like Earth. Today, it is a runaway greenhouse catastrophe, a vision of hell with surface temperatures hot enough to melt lead. Was its fate a natural process, or was it a murder? Mars, the frozen red desert, is now a tomb, but we know it once flowed with rivers and held vast oceans beneath a thicker atmosphere. What catastrophic event stripped it bare and left it to die? If a civilization on Earth can be so thoroughly erased by our planet's living geology, perhaps the clues to our own predecessors' fate lie on the dead, silent worlds nearby. This is the search we are embarking on. A search for a civilization that may have risen, reigned, and fallen while the dinosaurs were still young. A search not for their bodies, but for their echo. We are not just looking for another form of life. We are looking for a pattern, a cycle, a story that might be our own, written on a planetary scale. For if they did exist, and if they did perish, they may have seen their end coming. And in their final, desperate moments, they may have tried to leave behind a message, a bottle thrown into the cosmic ocean. A warning, intended for the next intelligence to inherit this world, that says, this is what happened to us. Do not make our mistakes. To ask where the cities are is to misunderstand the question. It's like searching for a single sandcastle after a century of storms and tides. Our instinct is to look for artifacts, for things we can hold and measure. But the timescale we're dealing with is so immense, so brutally vast, that it operates under a different set of physical rules. The Earth is not a passive museum that preserves our creations, it is an active, living system with a slow, grinding metabolism that recycles everything. To find evidence of a lost world, we must first understand the certainty of its erasure. Imagine our own civilization, with all its sprawling megacities, its deep-sea cables, and its orbital satellites. Now, press fast forward. In a few 100,000 years, every structure we have ever built would be gone, worn down to nothing by wind and rain and ice. In 1,000,000 years, the very foundations of our cities would be buried, crushed, and folded into new rock. The great engine of plate tectonics is constantly resurfacing the planet. The ocean floor we see today is, on average, less than 100 million years old. The older crust has been systematically dragged down into the Earth's mantle, a planetary-scale furnace that melts rock and memory alike. Any civilization that existed, say, 60 million years ago, would have lived on a continental configuration that no longer exists. Their world has literally been unmade, subducted into fire and reformed as new land. Their steel girders, their concrete highways, their silicon chips, all of it would be reduced back to its elemental state, a faint and meaningless mineral seam in a layer of rock that we might never find, let alone recognize. So, if we cannot look for the city, what do we look for? We must stop thinking like archaeologists and start thinking like forensic chemists. We are not searching for a body, we are searching for the chemical stain it left behind. We are hunting for technosignatures, global-scale changes to the planetary system that are so strange, so abrupt, that they cannot be easily explained by the natural rhythms of geology. We are looking for the shadow of a ghost. The first and most powerful shadow is written in carbon. All life on Earth, from the smallest microbe to the largest whale, is built from carbon atoms. But not all carbon is the same. There are different versions, or isotopes, and life shows a distinct preference for the lighter kind, carbon-12. Fossil fuels, coal, oil, natural gas, are the compressed remains of unfathomable amounts of ancient life. They are vast, buried reservoirs of light carbon. When an industrial civilization discovers how to burn these fuels for energy, it does something that nature never does. It exhumes billions of tons of this ancient, light carbon and pumps it directly into the atmosphere in the geological blink of an eye. This planetary-scale event would be recorded everywhere, in the shells of tiny marine organisms, in the layers of ocean sediment, in the chemistry of the rocks themselves. A geologist millions of years in the future would see a sudden, violent spike in light carbon and would have to ask, what could have possibly done this? The next clue is the unnatural molecule. Our industrial processes create compounds that have never existed in the 4-billion-year history of the Earth. Plastics are the most obvious example. Even as they break down, their unique molecular structures could persist in sediment as identifiable chemical fossils for millions of years. Then there are the more insidious chemicals, like the chlorofluorocarbons, or CFCs, that we once used as refrigerants. These potent, synthetic molecules were so stable they drifted into the upper atmosphere and began to tear a hole in the ozone layer. This was a global scar, inflicted by a molecule that could only have been made by technology. Finding the lingering decay products of such compounds in an ancient rock layer would be like finding a microchip in a dinosaur bone. It's a signature of chemistry that has gone off script, a sign that some intelligence had begun to rewrite the rules. Finally, we look for the fever. An industrial civilization doesn't just change the chemistry of the planet, it changes the climate. Dumping that much carbon into the atmosphere triggers a rapid, planetary warming event, a hyperthermal. Geologists can see evidence of past hyperthermals in the rock record. They appear as sudden changes in sediment type, mass extinctions in the fossil record, and dramatic shifts in ocean acidity. While these events can occur naturally, they usually happen over tens of thousands of years. An industrial civilization would cause one on a timescale of centuries. It would look, in the geological record, like the planet was struck by a sudden, violent fever. It would be a different signature from a natural catastrophe. An asteroid impact, for instance, leaves a thin, global layer of the element iridium. An industrial collapse would leave a layer of carbon, plastics, and extinction. It would be the fingerprint of a civilization that burned too brightly and burned out. This, then, is the new search. We are not digging for ruins, we are drilling ice cores and analyzing sediment layers. We are looking for the subtle anomalies, the chemical whispers that betray a world knocked off its natural course. The absence of a skyscraper does not mean the absence of a builder. It means we have been looking for the wrong kind of monument all along. The true monument of any industrial civilization, it seems, isn't what it builds, but the scar it leaves on the planet itself. If the Earth is a crime scene, it is a compromised one, contaminated by billions of years of its own geological activity. To find a clearer picture of what might have happened, we must expand our investigation. We must look to the silent, neighboring worlds that have kept a cleaner record of their own violent histories. Our solar system is not just a collection of planets, it is a family of stories, and some of them read like tragedies. The clues to a civilization's end might not be buried beneath our feet, but may instead be screaming at us from across the void. Our first destination is Venus. In the modern imagination, it is a vision of hell, but it was not always so. In the youth of our solar system, Venus and Earth were twins. For more than 1 billion years, it may have been a temperate world, a planet of vast, warm liquid water oceans, continents, and clouds. It existed within the Sun's habitable zone, a paradise next door. It had all the same ingredients for life that Earth did, and billions of years to work with. What would that world look like today if its story had continued uninterrupted? Would we look up and see a blue and green point of light in our evening sky, a second Genesis, a sister biosphere? We will never know. Because something went catastrophically wrong on Venus. Today, its surface languishes under an atmosphere 90 times heavier than our own, a pressure so immense it would crush a nuclear submarine. The temperature is a uniform 460 degrees Celsius, hot enough to melt lead. Its skies are a permanent, sickly yellow, and it rains not water, but corrosive sulfuric acid. Venus is the ghost of a garden, a planet that was tortured to death by a runaway greenhouse effect. The scientific explanation is that as the young sun grew hotter, the Venusian oceans began to evaporate, loading the atmosphere with water vapor, a potent greenhouse gas. This trapped more heat, which boiled off more ocean, which trapped more heat, in a feedback loop that ended only when the last drop of water was gone, cooked off the planet and stripped away by the solar wind. But this explanation, while scientifically sound, assumes a natural timeline. What if something gave that process a violent, unnatural push? Pumping billions of tons of carbon into the atmosphere is a very effective way to kickstart a greenhouse catastrophe. Could a Venusian civilization, in its industrial infancy, have unknowingly lit the fuse on its own planetary funeral pyre? We look at Venus today and see a warning. Its fate is a billboard in the cosmos, a graphic depiction of what happens when a planet's climate is pushed past the point of no return. Was this planetary murder-suicide? Or just a terrible, natural accident? From the inferno of Venus, we turn our gaze outward, to the cold, red silence of Mars. Here we find a different kind of death, not a fast, feverish one, but a slow, agonizing demise. We know, from the tireless work of our rovers, that Mars was also once a water world. We have seen the great, sweeping deltas where ancient rivers met vast lakes. We have found the chemical signatures of clay minerals that could only have formed at the bottom of a standing body of water. Mars was once a flowing, dynamic planet with a thick atmosphere and a protective magnetic field. It was alive. Today, it is a frozen, irradiated desert. Its atmosphere is a barely there wisp, less than 1% the density of our own. Its water is gone, either locked away as ice at the poles or blasted into space over eons. The scientific story of Mars's death is one of a cooling core. As its molten iron heart solidified, the magnetic dynamo that powered its protective shield sputtered and died. Without that shield, the relentless solar wind descended upon Mars like a wolf, stripping away its atmosphere molecule by molecule, until the planet could no longer hold onto its oceans or its warmth. But again, we must ask the question, was it a natural death, or was something else at play? What kind of technology could accelerate the death of a planet's core? Could a civilization engaged in a planetary scale war have fractured the crust, bled the world of its internal heat, and mortally wounded its magnetic field? Or perhaps their end was quieter. Maybe their own industrial pollutants poisoned their thinning atmosphere until it collapsed, triggering a feedback loop of cooling from which it could never recover. Mars is a different kind of cautionary tale. It's not about burning too hot, but about growing too cold. It's a story of a world that lost its breath, a ghost of a planet that suffocates in the silence of space. After touring these planetary tombs, we must finally return home, to the most complex crime scene of all. Here on Earth, the evidence is buried under countless layers of time. But there are anomalies, strange chapters in our planet's history that demand a closer look. 56 million years ago, the Earth experienced a bizarre and rapid global warming event known as the Paleocene Thermal Maximum, or PETM. For a few thousand years, global temperatures spiked, the oceans turned acidic, and mass extinctions rippled through the biosphere. Geologists have found the chemical fingerprint of this event, a massive, global injection of light carbon into the atmosphere. The leading scientific theory suggests this carbon came from immense volcanic eruptions that cooked vast deposits of coal and methane, releasing it all at once. This is the likely culprit. And yet, the PETM stands as a perfect analog. The carbon spike, the ocean acidification, the mass extinction, this is exactly what the geological footprint of a fallen industrial civilization would look like. While the PETM itself was almost certainly natural, it provides us with a template for what to search for. And it forces us to wonder, are there other, fainter, more mysterious events like it, buried even deeper in the rock record, that we have yet to find or cannot yet explain? Have we been staring at the evidence all along, without ever knowing what we were seeing? Let us assume, for a moment, that they saw it coming. That this hypothetical, ancient civilization, in the final centuries of its existence, understood the nature of its doom. Perhaps their planet was dying, their atmosphere unraveling, their climate spiraling into an uncontrollable rage. They knew they would not survive. This transforms our search from a geological mystery into a profound human, or perhaps, inhuman, story. It raises a new, more urgent question: if you knew your world was about to end, and you had a ghost of a chance to warn the future, what would you do? How would you write a message to a species that does not yet exist, in a language they could not possibly know, and on a medium that could survive the ravages of 100 million years? This is the ultimate challenge of interstellar, or intertemporal, communication. Every medium we use to store information is fragile. Our books turn to dust, our monuments crumble, our hard drives decay. Even messages carved into the hardest stone would be ground into sand by the relentless geology of the Earth. And language itself is the most ephemeral artifact of all. A message written in any tongue would be an indecipherable relic. The challenge is not just to preserve the message, but to ensure it can one day be understood by a completely alien intelligence, an intelligence that may not even have eyes or ears. Faced with this impossible task, a doomed civilization might have turned to the most fundamental languages of all, the language of physics, the language of life, and the language of location. Their first option would be to create a geological beacon. If you cannot preserve a single artifact, then you must create millions, and scatter them across the globe. You would need to manufacture an object from a material so unnaturally durable and so obviously artificial that its discovery would be undeniable. Imagine a thin layer in the geological record, seeded not with iridium from an asteroid, but with microscopic, perfectly spherical beads of a complex ceramic, or trillions of tiny, synthetic diamonds etched with a specific isotopic signature. A future geologist drilling a core sample anywhere on the planet would find this layer. At first, it would be a mystery. But upon analysis, the conclusion would be inescapable: this is not natural. This was manufactured. The message, in its first form, would be nothing more than the stunning realization that someone was here. The global distribution of the material would signal that they were a planetary-scale civilization. The specific properties of the artifact, perhaps its crystalline structure or isotopic ratio, could be a key, a primer for a more complex message, pointing the way to a second, more concentrated cache of information. A second, far more elegant solution would be to write the message in the language of life itself. DNA is the oldest and most successful information storage system on the planet. For nearly 4 billion years, it has been faithfully copying and preserving the blueprint for life, carrying it through every mass extinction, every ice age, every cataclysm. What if a civilization could hijack this system? They could encode their warning into a long, stable sequence of non-coding, or junk, DNA. Then, they would insert this genetic letter into the genome of the hardiest organism they could find, or engineer. They would choose a creature like a bacterium or a tardigrade, an extremophile capable of surviving radiation, the vacuum of space, and the crushing pressures of the deep sea. They would then release these living messengers into the world's oceans and deep Earth biospheres. The organisms would multiply, evolve, and spread across the planet, silently carrying their message within them. The civilization would perish, continents would drift, but the tiny messengers would survive. The message would lie dormant, copied from generation to generation for millions of years, waiting. Waiting for a new intelligence to arise, one that would eventually develop the technology to sequence a genome, stumble upon this strange, artificial sequence, and realize it is reading a letter from a long-dead world. But the most audacious plan would be to bypass the chaotic, destructive nature of Earth entirely. If your own house is destined to burn down, the only way to save your most precious belongings is to move them somewhere else. For an ancient civilization, there was only one truly safe place, the ultimate off-site backup. The moon. Our moon is a dead world. It has no atmosphere, no weather, and no plate tectonics. It is a cosmic museum where footprints can last for 1,000,000 years. A message placed on the moon, perhaps buried just beneath the surface to shield it from micrometeorites and radiation, would be safe for 1,000,000,000 years or more. This message could be anything, a library of their science, art, and history etched onto plates of synthetic sapphire, or perhaps just a simple, terrifying diagram showing the chemical equation that led to their downfall. The sheer genius of this method is that it has a built-in key. The message can only be read by a civilization that has achieved spaceflight. It can only be found by a species that has reached the same technological threshold that likely led to the messenger's own destruction. The lunar safe deposit box isn't just a warning, it's a final, poignant test, delivered at the exact moment the recipients need to hear it most. Our search for this ghost civilization has taken us from the acid hell of Venus to the frozen deserts of Mars, from the deep rock of our own planet to the silent sanctuary of the moon. We have pursued the faintest of chemical trails and imagined the most ingenious of messages. But throughout this entire investigation, we have been operating on a fundamental assumption, that we are searching for a specific, singular event. We have been looking for a civilization, a warning, a story. Perhaps it is time to zoom out, to see our solar system not as an isolated case, but as a single data point in a much larger, and much more terrifying, cosmic equation. The universe is silent. This is one of the most profound and unsettling facts of modern science. We live in a galaxy of 400 billion stars, which is itself just one of 2 trillion galaxies in the observable universe. The numbers are so mind-numbing they defy comprehension. Given so many opportunities, so many worlds, and so many billions of years for life to arise and evolve, our galaxy should be a blaze of activity. It should be a cosmic metropolis, humming with the signals of countless civilizations, a place where interstellar travel is commonplace. And yet, when we point our radio telescopes to the sky, we hear nothing. An eerie, unnerving, cosmic silence. This is the Fermi paradox. Where is everybody? One of the most compelling, and most chilling, answers to this paradox is the theory of the Great Filter. The theory proposes that on the long, arduous path from the first spark of life to a galaxy-spanning civilization, there exists a wall, or a filter. This filter is a challenge or a transition that is so difficult, so improbable to overcome, that almost no species ever makes it through. For some, the filter might be the initial leap from non-life to life. For others, it might be the jump from simple cells to complex, multicellular organisms. But a darker possibility exists. What if the Great Filter isn't in our distant past? What if it lies just ahead of us? This is where our search for a lost civilization becomes a search for ourselves. The true warning may not be a message written in stone or DNA. The warning may be the silence itself. What if the Great Filter is the very nature of industrial intelligence? What if the discovery of technology is a universal trap, a poison chalice offered to any species intelligent enough to grasp it? The moment a civilization learns to burn its planet's ancient sunlight, it starts a clock. The moment it learns to split the atom, it gains the power to unwrite its own future in a flash of light. The moment it creates an intelligence greater than its own, it risks becoming the second most intelligent species on its own world. Look around. The challenges we face are not unique to our politics or our time. They are the predictable consequences of planetary-scale engineering. Climate change is not a human flaw, it is a law of physics. Any civilization that powers itself by burning massive quantities of hydrocarbons will inevitably alter its planet's climate. Nuclear proliferation is not a failure of diplomacy, it is a failure of game theory. Any civilization that discovers nuclear fission will have to live forever with the knowledge that it can annihilate itself in an afternoon. Uncontrolled artificial intelligence, genetically engineered pandemics, ecological collapse, these are not our private demons. They are the great filters of the cosmos. They are the final exams that every technological civilization must pass, and the evidence, written in the silent sky, is that almost nobody does. From this perspective, the story is no longer about ancient aliens. It is about us. The ruins we have been searching for in the deep past might not be there, because we are building them right now, in the present. We are the Silurian civilization. The sudden spike of carbon we are pumping into the air, the synthetic plastics and pollutants settling in a thin layer across the globe, the sixth mass extinction we are currently engineering, these are our technosignatures. We are creating the very evidence that a future intelligence, perhaps millions of years from now, might one day dig up and wonder about. The ghost we are chasing is not a relic of the past, it is a shadow of our own potential future. The warning isn't out there, waiting to be found. It is in here. It is the hum of our power plants, the glow of our screens, the uneasy feeling that our greatest achievements may be inextricably linked to our ultimate demise. We began this journey with a question that echoes from the deepest chasms of time: did someone come before us? We set out in search of a whisper in the rock, a shadow in the solar system, a final, desperate message from a world that died so that we might live. We have sifted through the ashes of dead planets and the layers of our own geological history, hunting for the ghost of a lost civilization. But what if, after all this searching, we have discovered that we were never really looking for a ghost at all? What if we were simply looking in a mirror? We do not need to find an artifact, because the warnings are not buried. They are not hidden. They have been staring down at us, in plain sight, for the entirety of human history. Venus is not a mystery, it is a monument. A monument to the unforgiving physics of a runaway greenhouse effect. It is the solar system's most brutal lesson, a testament to how a paradise can be transformed into an inferno. Its message is not written in an alien language, it is written in thermodynamics and atmospheric chemistry, and it says, this is what happens when a world's climate is pushed beyond the brink. This is the end of that road. Mars is not a riddle, it is a eulogy. A eulogy for a world that lost its breath. We see its dried-up oceans and its silent, windswept riverbeds not as clues to an ancient war, but as a testament to the fragility of a biosphere. Its shield failed, its atmosphere was stolen by the sun, and its life-giving water vanished into the void. Its message is written in the language of planetary science and magnetic fields, and it warns, a world is a delicate machine. Its protections are finite. Do not take your sky for granted. And what of Earth? We have been searching its deep history for an anomaly, a sign of an unnatural catastrophe. But its entire history is the warning. The geological record is our planet's own diary, filled with chapters of climate chaos and biosphere collapse. The great extinction events, the hyperthermal periods, the ice ages, these are not just academic curiosities. They are case studies, meticulously recorded in stone, showing precisely how this world responds to being wounded. The Earth has told us, again and again, what happens when its vital signs are altered too quickly. We have been searching for a single message in a bottle, when we are living inside the library. Perhaps we've been asking the wrong question all along. The question is not whether some long-lost civilization tried to warn us. The real question is whether we are intelligent enough to heed the warnings that the universe provides for free. The laws of physics are the ultimate, impartial messengers. They are the great filter. They do not care about politics, or economics, or belief systems. They simply are. They deliver the same lesson to any species on any world that begins to tinker with the energy balance of its own planet. The warning is a universal constant, etched into the fabric of the cosmos itself. And the ghost civilization we have been searching for, the one that leaves behind a spike of carbon, a layer of strange pollutants, and a wave of extinction, is not a ghost of the past. It is the ghost of our own potential future. We are the ones leaving the techno-signatures. We are the ones conducting the planetary scale experiment. We have become the very thing we have been looking for. The silent, empty sky of the Fermi paradox may not be a sign that life is rare, but that a particular kind of intelligent, industrial life is tragically, and predictably, self-limiting. So the search ends not with an answer, but with a choice. There is no ancient secret to unearth, no alien savior to guide us. There is only the cold, hard data of the worlds around us, and the ticking clock of our own planet's chemistry. The ultimate question is not what they did, but what we will do now. We are the ones we've been waiting for. And the universe is watching to see what we decide.